This is the formula to get volume. V equals pi times the integral of r squared derivative of x, where V represents volume and r squared represents radius squared. By getting the integral of radius squared, we are taking a piece of the shape, so by the time this is multiplied by pi, it sort of makes a turn, filling the 360 degrees of the shape, going from a flat shape to one that has its own volume.
In order to get the measurements of the bottle, we cut it in half, so it'll be easier to analyze and proceed to physically get an approximate drawing and get the measures of the bottle. Now with the drawing, we enter the equations that we thought were necessary to get the graphic representation, and with the colors that appear on Desmos, we splitted the graphic and arranged each color division with its corresponding equation.
Alright, so the first thing you want to do in this part is write down the equation exactly as it is. So right now the equation is y equals 3.9 with a limit in 0 and 4.2. So once you have that, you're gonna substitute the values in the formula of volume, which in this case is gonna read volume equals pi times the integral of 3.9 squared derivative of x. Then afterwards, you're gonna solve the integral. So first you want to get the value without the square, so you solve that first. So afterwards you're gonna have volume equals pi times the derivative of 15.25 derivative of x. Then after you have that value, you're gonna integrate that, and you're gonna have pi times 15.21x. That's gonna be your new equation. So with that equation, you're gonna have to find about two values, one with the upper limit and one with the lower limit. You're gonna substitute x as the upper limit, and then you're gonna have to substitute x on the lower limit. With the upper limit, it's gonna read 15.25 times pi times 4.2. In the other part, it's gonna be 15.25 times pi times 0. So first thing you're gonna do is, with the upper limit, you're gonna subtract the lower limit, which in this case is 0. So you're only gonna get the upper limit as the volume, and that's gonna be in units cubic.
So we repeated the procedure with all the equations. Then, when we had all the results, we added them all up, and that's the total value of the volume.